Hi, morning, everyone. My name is Wuyang Chen, and here is our fifth UG2 fifth version of the UG2 challenge and workshop. And I think our audio and the screen sharing and the video should be okay. And if you have any problem, please feel free to send us any messages to the chat, and we will have some co-hosts to help coordinate, see if any problems. And I'm very glad to see that our UG2 workshop is now 5 years old, and every year we bring new data set, new challenges, and new speakers on different topics to our workshop. So to keep our workshop alive and keep updated to the community. And this year, our 3 topics on the challenge includes the dehazing and action recognition in dark videos and air turbulence. So it's still a very hot topic and long-lasting topic about understanding and resolving the degraded visual environments in the machine learning system. So nowadays we can still see many different kinds of downgraded or perturbed images or videos in our daily lives and even in many standard ML pipelines, like the blurred ones or low light ones or raining or hazing. All these kind of images are uploaded or processed in many cloud machines or ML pipelines, even on our edge devices. So most of the applications are actually trained on standard images, but these all degraded images are not well handled by many standard ML pipelines. And another important issue is that when this kind of images are actually a kind of domain shift to the ML system. So it's very easy for the ML system to train on standard images, but then forget and then fine tune on this downgraded images, then forget about the original distribution. So this kind of degraded data can raise a lot of problems. So as I mentioned before, the current system is trained on many clear environments, but this in real life needs, we actually are facing many different kinds of complicated unconstrained degradations. So what's our aim? Actually, our aim through these 5 years are not changed. We always seek to first build large-scale data sets that is collected from various degraded visual environments. And then we hope to leverage these large-scale data sets to provide both the low-level enhancement algorithms and then seek to bridge the gap between the low-level algorithms and the high-level application algorithms. So these 2 goals are not changed in these 5 years, but we keep improving both our data set and our algorithms. And this is the past 5 years, and we keep improving the challenges. And in this year, we have first time we have 3 challenges: the object detection in haze, and we have the action recognition from the dark videos, and we also have the atmospheric turbulence mitigation. And since we have 3 challenges this year, we have a breakthrough in both the number of teams that registered and also the number of final submissions to our challenges. And we have 289 teams, which is about 100 more than last year. And for the final submission, we have 400 successful submissions, which is almost double last year. And then we have 9 teams that is awarded. And we would like to share our warm congratulations to these teams. Okay, the first challenge in our workshop this year is about the object detection in haze. Although we have seen many haze data sets for either detection or segmentation in the past few years, our data set this year is the first time that our data set first the fog is real in the pictures, and then it is the magnitude of the fog is controlled, and then it is paired. We have all the objects in the data sets they are all paired. So we have a clean image with objects in there, and we keep the position of the objects unchanged, and we keep changing the magnitude of the fog. So everything is real and paired inside our data set. And also, this is the area data set since we have a drone flying on top of the objects and taking the photos from top to down. And we have 177 paired haze and clean images, which the frame selected from 12 videos, and we also have annotated clean image for the vehicles. And then we have 50 haze images reserved for the fine testing. So this whole data set is a small scale, but we also allow the teams to use any unlabeled extra data set. So our best team can even achieve over 90% of the MAP from the University of Science and Technology of China. And actually all three teams are above over 93 MAP. And the second one is from Alibaba Group from China. And also the third one is from the South Korea. Then for the next change, I'm about to shift to Yuesong. Yuesong, can you hear me?
Yes, hi. Can you hear me from there?
Let me unmute you actually. Just 1 second.
Can you hear from me? I think I'm already unmuted.
You are also the co-host, right?
Yes, correct.
1 second. Please allow me a second, just 1 second. Could you check send message to the WeChat group to see this is him? I see.
Hi, can you hear me?
So you turned your mic on, right?
Yes. Okay. I think I think the says that they can hear you,
but
there's no sound in the scene live scene, right?
So, could you can you hear Yuesong's voice from your laptop? Okay. Yuesong, just 1 second. Yuesong, could you have a try?
Hi. Can hear from me?
Yeah. Yeah.
Okay. Cool. Okay. So hi everyone. I am Yue Cong from the Institute for Infocom Research in Singapore. I'm very glad to present our this year's challenge on action recognition from dark videos. Okay, so this is actually the second year we've held this challenge in this UG2 plus challenge and workshop. So we noticed that while action recognition has been applied in various real-world scenarios, such as smart homes, autonomous driving, etc., actually most current action recognition methods focus on videos shot under normal illumination. So in the meantime, there are various scenarios where videos shot under adverse illumination, or for example, in the dark, is actually unavoidable. For example, scenarios such as night surveillance or autonomous driving at night. So it is actually therefore highly desirable to explore possible methods that are robust and could cope with these scenarios. This is in line with the trend where over the past few years, there has been a remarkable rise of research interest with regards to computer vision tasks in dark environments, which have been actually expanded to the video domain more recently. Meanwhile, given the high cost of video annotation, it will be unlikely that such videos are labeled exhaustively in real-world scenarios. With the availability of a variety of large-scale labeled videos shot under normal illumination, this challenge aims to fully utilize these videos with possible pre-processing or post-processing steps to capture actions with high robustness towards darkness. So therefore, the UG2 Plus Challenge Track 2 aims to promote video-based action recognition algorithms, robustness with special focus on dark videos. We drive these participating teams to utilize semi-supervised algorithms, which could utilize both clear videos and dark videos. Furthermore, given the high cost of video annotation, this challenge also aims to elevate the importance of eco-friendly and efficient learning by decreasing annotation costs. This challenge is actually based on the ARID dataset, which is the first real-world dark videos for action recognition in dark environments. Okay, the next slide, please. Okay, so we can see that compared to last year's edition, this year our challenge have been vastly upgraded. We've included 11 categories of daily actions, up from 6 from last year, and also our data set has been largely expanded. You can see that we've included almost doubled the number of videos provided to the participating teams. And so for this year, there's actually a total of around 6,000 videos provided, both dark videos and normal videos from current public data sets. For the testing videos, we've also largely upgraded from 722 videos of last year to 3,100 videos of this year. And we've also seen a very large rise in the number of participants as well as valid submissions, with almost 5 times, actually more than 5 times, the number of submissions, valid submissions from 20 teams. And we can see that the competition is actually very fierce among the teams, especially among the top teams, where actually there's only a 5% gap between the top 5 teams. And so here I would like to congratulate our top 6 teams. So the first team is from TAL Education Group with an accuracy of actually around 91%. The second team and the second runner-up, so the first runner-up and the second runner-up actually is just divided with only 1 sample. So the first runner-up is Nightcrawler from Shenzhen Institute of Advanced Technology, CAS. And the third team is actually from Sun Yat-sen University, Titan 5 HPL. And due to the very close results, we would also like to honor the 4th to 6th teams, which are from Sun Yat-sen University, CT Yun, as well as a collaboration between Shanghai Jiao Tong University, NUS Singapore, and Meitu. And that's it from my side. Thank you very much. I pass on to the third track.
Thanks, Yue-Song. And now let's welcome the Zhiyuan from the third challenge to introduce his challenge.
So, hello everyone. I am Zhiyuan Mao from the Purdue University. So, the third track of the UG2 Plus challenge focuses on the imaging through atmospheric turbulence. Atmospheric turbulence is a fundamental factor that limits the performance of the high-resolution long-range imaging systems. Imaging through turbulence is both an old and a new problem. It is an old problem in the sense that this problem has been studied by the astronomical imaging area and by the optics society for decades. So there are really a lot of tools that are ready to use. However, it is also a new problem in the sense that what we are looking at is the near-ground horizontal imaging. This is bringing a lot of new perspectives and challenges to the field. For example, our image will have a lot more diverse image contents. We are also probably handling some moving objects across the scene. In addition, the acquisition device, the cameras that we are using may also pose some new limiting factors here. So recent years, we can see that there's an increasing interest in the problem of imaging through turbulence because there's an increasing interest in the long-range visual recognitions. So our third track aims to promote the development of the atmospheric turbulence mitigation algorithms. So participants will design the image reconstruction algorithms to remove atmospheric turbulence effects from multiple input frames. Okay, so we will evaluate the reconstruction algorithms with the text recognition accuracies. So for utilities, we provide 500 long-range text sequences for text recognitions. In addition, we also have 50 artificially synthetic hot air turbulence sequence, which contains aligned turbulence distorted and clean image pairs. This can be allowed for use for PSNR calculations. All the training data used in this challenge are synthesized by our latest physical-based simulators. So this year, we have winners from the TAL education groups. We also have runner-ups from the Tech University of Korea and the University of Maryland. So congratulations to the winners. Finally, as a closing remark, we are planning to run the same challenge next year as well, with some upgraded new data sets. So stay tuned to our website. Thank you.
All right, thanks, Zhiyuan. And we appreciate the great our great sponsors from NVIDIA and Army Research Lab. And as Zhiyuan mentioned before, that we will continue our challenge next year. So keep tuned on our website, and we will broadcast our new challenges and perhaps new data sets. Thank you very much.